Welcome back to the Elon Musk Signal channel. This week promises to be a busy one with rocket launches. It won't be long before SpaceX's majestic Starship rocket lifts off once again. This test flight is expected to deliver the most spectacular performance to date. To achieve this, SpaceX has made significant changes to the entire structure of the rocket, improvements that you may not yet be aware of. So what are these improvements? Do they ensure the mission's success? Let's explore in today's video. The company announced over the weekend that they are targeting Thursday, June 6th, for the fourth test flight of Starship, the largest and most powerful rocket the world has ever known. Starship is ready to fly, SpaceX founder and CEO Elon Musk wrote in an X post on Sunday, June 2nd. Starship has significantly improved with each successive flight. Its two stages, the Super Heavy booster and the upper stage Starship, failed on the first flight, lasting only 4 minutes. The vehicle passed the separation stage on the second launch and doubled its flight time. Starship achieved orbital velocity on the third flight, lasting nearly 50 minutes before ending with the upper stage rupturing upon re-entry into Earth's atmosphere. The orbit of the fourth flight will be similar to that of the third, with Super Heavy aiming to splash down in the Gulf of Mexico and the upper stage aiming to land in the Indian Ocean. Our fourth test flight shifts our focus from achieving orbit to demonstrating the ability to return and reuse Starship and Super Heavy, SpaceX wrote in a mission description. The primary objectives will be to perform a landing burn and soft splashdown in the Gulf of Mexico with the Super Heavy booster and achieve controlled re-entry of the Starship. Preparing for the fourth test flight, SpaceX's Starship rocket is sporting a new look with a series of remarkable upgrades. The ultimate goal is to maximize mission success. Lessons learned from previous test flights, whether successful or unsuccessful, have been maximized. Based on these analyses, SpaceX has implemented a series of hardware and software upgrades for Starship. First, let's explore the hardware changes in the second stage of Starship. This is the area where SpaceX has focused its most intense improvements, aiming to enhance heat resistance during atmospheric re-entry and ensure safer flight control. The heat shield, the part protecting Starship from the intense heat during its return to Earth, is a top priority for Elon Musk and the SpaceX team. Lessons drawn from previous tests, where Starship encountered issues during re-entry, led SpaceX to meticulously eliminate cross-seam welds, potential weak points on the heat shield. Additionally, each tile of the heat shield is carefully installed, significantly increasing heat resistance. In addition to physical improvements, SpaceX has addressed issues related to flight control through hardware upgrades. Furthermore, an additional set of thrusters has been installed to ensure redundancy. Even if some thrusters malfunction, others can compensate, maintaining precise flight direction. SpaceX is not only focusing on improving the rocket but also comprehensively upgrading the launch pad. Booster 11, responsible for propelling the rocket during the initial stage, has been overhauled with a series of upgrades for durability and reliability. One of the most notable changes is the reinforcement of the methane tank structure. The inner framework of the tank has been significantly strengthened, from 24 to 74 support ribs. This is to substantially increase the tank's resilience, particularly during the most stressed stages such as launch and atmospheric re-entry. Additionally, SpaceX has reinforced additional support points and reinforcement bars underneath the grid fins, doubling the thickness in areas subject to high stress. These structural improvements promise to minimize the phenomenon of bending and potential damage when the launch pad is not pressurized or subjected to the impact of re-entry forces. Furthermore, SpaceX has fine-tuned the ventilation and venting system of the launch pad. Deflectors on the vent holes of the lock tank have been significantly reinforced to withstand harsh re-entry conditions. A new double-pane deflector shield has also been installed on the methane tank, substantially increasing its strength and resilience. One common issue in previous test flights has been filter clogging, leading to sudden engine shutdowns. To address this challenge, SpaceX has significantly improved the fuel filtration capability of the launch pad. The new filters will effectively remove contaminants that could cause fuel line blockages, ensuring durable and stable engine operation. In addition to hardware upgrades, SpaceX has fine-tuned the Raptor engine ignition process during the landing phase. This helps ensure smoother and more reliable ignition. These comprehensive improvements, from structure to systems, are pivotal for a successful flight. Not stopping at hardware upgrades, SpaceX has set ambitious goals for Starship in the fourth test flight. The main objective of this mission is to validate safe splashdown and enhance reusability for both the booster and the Starship. For the booster, SpaceX will perform a virtual tower catch maneuver. The booster will aim for a precise location in the Gulf of Mexico, simulating the required accuracy for the Mechazilla system in the future. This is a crucial test to demonstrate precise control of the booster during re-entry and landing. As for Starship, it will attempt propulsive landing for the first time. Instead of relying solely on aerodynamic surfaces, Starship will use its engines to decelerate and control the landing process. The key factor in this process is maintaining precise orientation during atmospheric re-entry, a prerequisite for ensuring the effective operation of the heat shield and control surfaces. This is the landing flip maneuver that SpaceX has just announced in the latest update for the fourth flight. In the previous test, the third flight, SpaceX did not perform the belly flop maneuver as the mission focused on demonstrating the fuel transfer feature, pumping methane from the upper tank to the main tank. Furthermore, this mission introduces a new element: the removal of the hot staging ring after the booster completes the initial acceleration phase. By eliminating this component, SpaceX can reduce the weight of the booster, significantly improving control and performance during landing, thereby increasing the success rate of recovery. The fourth test mission of Starship is not only a spectacular landing maneuver but also a significant milestone for SpaceX's long-term goals. Although restarting the Raptor engines in orbit will not occur in the fourth flight, it remains a critical test for the future. The ability to restart engines in orbit is vital for spacecraft control, ensuring safe re-entry and return to Earth, rather than becoming uncontrolled debris in space. The success of this test will ensure sustainability and safety for long-duration space missions. In addition to refining the re-entry process, SpaceX aims to deploy satellites as a significant milestone by the end of this year. It's highly likely that Starship will be used to launch and deploy Starlink satellites. This is a practical test for Starship's capabilities, as well as an opportunity to fine-tune satellite deployment mechanisms. The success of this mission will contribute to expanding SpaceX's satellite internet constellation. Using Starship for these launches not only expands the spacecraft's capabilities but also demonstrates its potential for efficient and frequent cargo transportation. Each successful mission, each milestone achieved, reinforces confidence in the reliability and readiness of Starship. This solid foundation sets the stage for more ambitious projects in the future, such as building larger versions of Starship and reaching even bolder goals. Let's look forward to the surprises that SpaceX will bring in the future. Thank you for watching the entire video. Please leave your comments about today's video. We look forward to constructive feedback from you. Don't forget to like, share the video, and subscribe to the channel for continuous updates on interesting information. Goodbye and see you in the next video.